Dóra Cseresznyés and I work from the Geological Survey of Hungary. Yes. And yeah, in the next few minutes, I would like to just um, present the perspective of CCS in Hungary. But first, let me introduce just our team. Um, where geologists, geochemists, and geophysics with environmental researcher working together and in a collaboration with universities and research institutes as well. And our main question or the theme focusing on what processes can take place in a CO2 water rock system during the CCS project or on geological time scale. And what we do, firstly, we are working on the preparation and informants of regulation in the authority. In 2022, the previous government decree, which was established in 2012, was modified and supplemented. And now it's called the new degree. It's called Geological Structures Suitable for the Storage of Carbon Dioxide of Energy and Industrial Origin are in currently force. And to apply for a geological prospecting license is in Hungary. It is essential to submit the application, which includes the exploration work budget, the exploration plan map, the proposal for the amount of the exploration assurance, and in the exploration work program should be the most detailed, which contain the research test, the technology description, and planned exploration facilities, and of course the timing and the short geological background of the area, and a detailed budget for the exploration is also required. Some weeks ago, the authority got the first application, which is under consideration currently. It aims to inject CO2 in deep saline aquifers, which would be prospective. So the first little step, the interest of a company who wants to take a real action in the direction of CCS is happened. So we are, which are very good news for us. The other focus of our team is research and development. It is important for us that university students can to our work. And usually we go to on field trips and we are investigating natural CO2 occurrence in Hungary and collecting core samples from the drill core repositories and carry out petrophysical and geochemical analysis of the rock. We also collecting gas and water sample in the field and make some stabilizer analysis as well. We also run and develop geochemical modeling and carried out some laboratory experiments as well. We are in a close and strong cooperation with the two main CO2 producer and seller company in Hungary, who provides access to their wells and accumulated data. So let me introduce you quickly the geology of the Pannonian Basin, where Hungary is situated. So the basin is filled up mostly by Neogen sediments, and where mostly the Middle Miocene and the Late Miocene formations have potential for CO2 storage. And in Hungary, the EOR was started in the 1970s, and the reservoirs is mostly sandstone, carbonate, and fracture metamorphic reservoirs. Because of the geological background of the basin, we are focusing the two major groups of the geological structures, the depleted hydrocarbon fields and the deep saline aquifers, and the advantages of the deep saline aquifers in the basin that they have a regional extent. Their top depth is deeper than approximately 900 meters. Um, and it is regional covered by thick, low permeability strata, which is good in case of a CO2 storage project. During the screening procedure, we focus in these two major groups. And here you can see the depleted hydrocarbon sites in this figure with purple fields indicated that we are chosen. And these sites fulfill the requirements that you can see on the left side. Um, in case of the deep saline aquifers, the formation which is fulfilled the requirements is presented in a green color, and as you can see, their area is vastly bigger than the depleted hydrocarbon areas. And accordingly, the estimated storage capacity of these two structures are quite different. Around 100 million tons of CO2 can be potentially stored in depleted hydrocarbon sites. Meanwhile, a much bigger amount, around 760 million tons, may be stored in deep saline aquifers. But it should be noted that it was a volumetric estimation, so the real capacity is probably smaller. Um, as I mentioned before, we are also investigating natural CO2 sites in Hungary, which is located in the western part of Hungary. And the CO2 trapped in a Pannonian sediments around 7 million years ago and safely trapped in both sandstone and limestone formation from the two localities, Mihály Répcelak and Pöböl. Mihály Répcelak is the bigger one, which trapped 25 million tons of CO2 in a sandstone formation, and Pöböl is the smaller one, and it around 80 million tons of CO2 trapped in a limestone formation. Mm, but it should be noted that these two localities are still exploited currently for CO2 production. The in case of the sandstone formation, we have the unique opportunity to investigate the naturally CO2 flooded sandstone and the CO2 free state. Here you can see some scattered electron images of the core samples and a schematic figure which um, explain the processes. So we just compare the mineralogy and other things, and we just to summarize our results, that the CO2 firstly trapped in the pore space, then dissolved in the pore water, which resulted carbonates like calcite and feldspar dissolution. Then a new carbonate phase formed, which called Dansonite, as a response of the CO2 inflow in the system. So the CO2 trapped in a mineral phase, this newly formed carbonate. So we were lucky to observe that mineral trapping. In case of the other natural CO2 site, which is where the CO2 trapped in a limestone formation. It is a brand new research area for us, so we have a lot of open questions. So, for example, can mineral trapping of CO2 happen in limestone reservoir, or can the CO2 dissolve partially the host limestone and cause drastic changes in the reservoir properties on human or geological timescale? And finally, I would like to draw your attention to some interesting news on a pilot project in Hungary. A cooperation between the Siemens and Small Group was conducted in Nagylandia in a depleted hydrocarbon reservoir. It's called the Next Gen Geothermal Power, and they use emitted CO2 as a working media for geothermal power generation. And the pilot project was successful, so we hope that further developments also will be made into this topic. And last but not least, we also working on the screening methods of potential reservoir for hydrogen storage. So you can see a preliminary results that we focus on. Um, and we already have an ongoing project in Hungary in Kardoskut, where hydrogen storage is planned to be carried out in a depleted hydrocarbon field. And we also working on lab experiments and geochemical modeling in hydrogen in the topic of hydrogen storage. And if you want to know more about our research and work, just check our publication or send a message. And thank you for your attention.